Welcome, curious minds. Ever wondered why certain objects float on water, like a buoyant duck toy or beach ball, whereas others plunge deep, like an anchor or chunk of metal? Well, hold on to your curious caps because we're about to crack the code. It all comes down to a sneaky scientific superpower called density. You see, density is like a secret code that tells us how much stuff is packed into something. The more tightly packed, the denser it is, and the denser it is, the more likely it is to sink. Now let's unravel the formula to calculate density. It's the object's mass, measured in grams, divided by its volume in cubic centimeters or milliliters. Here's an illustration of that. You are looking at two different materials. Two materials share the same volume, but the atoms or molecules in the left one are loosely packed, creating lots of empty space. This results in a low density material. On the other hand, the same atoms are tightly packed in the second material, giving it larger density despite the identical volume. In today's experiment, we will demonstrate how we can calculate density of the material shown here. Instead of water, we use cranberry juice to make it more visible. First, we will be checking the accuracy of our scale with a 20-gram weight, and it looks perfect. Here is a graduated cylinder to measure the volume of liquids. My sister is helping here to tare the weight so we can measure the mass of the liquid accurately. Now I am carefully adding the colored water into the graduated cylinder. In this case, I'll be adding 50 milliliters. With the help of a pipette, I am making sure it is exactly 50 milliliters, and as you can see, it weighs 50.09 grams. Since we know both mass and volume, we can calculate the density of the colored water. 50.09 grams divided by 50 milliliters equals to about 1 gram per milliliter. So now we have the density of this colored water. We will be doing this math with other objects, and trust me, with practice it gets easier. Now we are ready to move forward with the other items. We will start with the foam. Since the foam has a regular shape, we can calculate its volume by measuring its dimensions in centimeter and multiply them. Its length is 8.5 centimeters, its depth is 7 centimeters, and its height is 4 centimeters. So 8.5 times 7 times 4 equals 238 cubic centimeters, or 238 milliliters. Now we need to weigh its mass. It is 6.27 grams. Now let's do the math. 6.27 grams divided by 238 cubic centimeters equals to almost 0.03 grams per cubic centimeter, which is the same thing as 0.03 grams per milliliter. Compared to 1 gram per milliliter, which is the density of water, this number is so small. We will continue our experiment with the egg. Now we will measure the density of the egg. Now you already know that we need the mass and the volume of the egg to calculate its density. Mass is a piece of cake with the scale. For the volume, we will use the liquid displacement method, which means the volume of the egg equals the amount of water it displaces from a container. To do this, we will need two containers. We take one large beaker and place a smaller beaker inside. Make sure the smaller beaker is large enough for the egg. To measure the volume very precisely, we do not rely on the numbers that are on the large beakers. Therefore, we top the smaller beaker with the liquid, and we will measure the amount of liquid displaced with a more precise graduated cylinder. Now I will drop the egg into the beaker filled with liquid, and of course the colored liquid spills over into the larger beaker. Be careful, the egg has to be fully submerged to measure its volume correctly. Also, try not to insert your finger into the liquid in this step.
Now I can measure the amount of liquid that spilled over into the beaker. Here we are using a graduated cylinder which shows that the water collected equals to 52 milliliters, which is the same thing as the volume of the egg.
Let's measure the mass of the egg using our super duper scale. Make sure the egg stays on the scale. And we see it weighs 56.46 grams. Now using the formula, we can calculate its density. 56.46 grams divided by 52 milliliters equals about 1.08 grams per milliliter, which is slightly larger than 1. This explains why the egg sank at the bottom while we were trying to measure its volume.
Let's now move on to our delicious apple. In this case, let's start with the easy one. Its weight is 162.71 grams.
It is time to measure the apple's volume. We will use the same trick again. Here I am also using a fork to make sure it's fully submerged in the water. This should give you a hint about its density, right? I have fully submerged the apple into the water, and now it is time to measure the volume displaced by the apple. The apple is much larger than the egg, the amount of water displaced by it is also large. Therefore, I am using a larger beaker to measure its quantity. I have also added 200 milliliters, and there is still some left. I'm using a graduated cylinder to measure the rest, and the amount left over was 10 milliliters. So the total is 200 plus 10 milliliters, which equals 210 milliliters. Now we can calculate the density. 162.71 grams divided by 210 milliliters equals 0.77 grams per milliliter, so the density is smaller than 1. Now it's time to test them all together. We know that the density of the colored water was about 1, so anything with the density lower than 1 should float, and things with a density higher than 1 should sink. Let's start with the foam. It has a huge volume, but it weighs about 6 grams, so it cannot replace much water, and it floats on water like a happy little duck. Now let's try the egg. As you remember, the density of the egg was 1.08 grams per milliliters, which is larger than 1, so the egg sank to the bottom. And finally, let's check the apple. Remember, it has a density of 0.77 grams per milliliter, so it's lower than 1. It floats on water. My curious sister is pushing it down, but it does not stay down there once she stops pushing it, thanks to its lighter density. We hope that this helps you understand why some objects float on water while others do not. You might be thinking that big ships made of metal should also sink as they are heavy, right? Well, keep in mind that those ships are made into a very specific shape. While the weight of the ship could sink it into water, the inside of the ship has lots of empty space, which means all that space is filled with nothing but air. And this lowers the average density of the ship and allows it to float on water. Let's demonstrate that with the metal cup. It can float on water despite its heavy weight. As you can see, the inside of it is nothing but air, similar to the bottom part of those large ships. Now, if we replace that air with something else, such as water, you see that more of the metal has gone into the water, and the average density has increased. Now, if we keep adding water, density will keep increasing, and once it passes 1, which is the density of water, then the cup will sink. This is similar to ships when they have an accident that takes water inside, just like the Titanic. This concludes our video. If you like our video and you would like it to reach other curious minds like yourself, please like and subscribe. I've heard that this helps a lot with the YouTube algorithm to reach the right audience. Also, don't forget to comment below. We are interested in hearing what kinds of experiments you'd like to hear next. How about the contents of our video? Was this too simple or too complicated? All these comments will help make our experiments more helpful for all curious minds. Stay curious and see you next time.